In this video, we're going to analyze the behavior of a specialized shift register. The figure you see here shows the shift register we're going to analyze. It mostly looks like a typical shift register, except for the fact that it has an AND gate feeding into the second most significant bit, and this AND gate is taking a combination of the most significant bit of the shift register along with the input. And so while we might be able to analyze this to figure out the behavior just by inspection, it may help to look at a waveform and see how this behaves over a sequence of different inputs. And so this shows the waveform that we're going to look at, and it's showing the input in the clock, and it's also showing an intermediate signal D2, which is going into the second flip-flop, since this is the one that behaves a little differently because it is coming from the AND gates. And then we've got the current contents of the shift register as well as the output. And so to help us out, it may also help to have some equations for both D3, which is just equal to the input, as well as D2, which is equal to the input, and with the current value of the most significant bit. And we could do the same thing. We could say that D1 is equal to second most significant bit, and for D0 it's equal to Q1 in this 4-bit shift register. And so to analyze this, we're going to look at D2 initially. Since in is 0, that means D2 is also 0. When in becomes 1, we could consider if it changes, but since Q3 is still 0, that means D2 is going to remain 0 at this point. And the output, which is Q0, is also 0, so that means we're going to remain 0 here. On the rising edge of the clock, we're going to shift values into the shift register. So the input is currently 1, so that means Q3 is going to take on the value of 1. Q2 is going to take on the value of D2, which is currently 0, and D1 and D0 are taking on the previous values of Q2 and Q1, and so that's our current value or current contents of our shift register. That means that on the right, or just after the rising edge of the clock, both in and Q3 are 1, so that means D2 will go to 1. And it would stay this way until something changes. In changes to 0, so that means D2 is going to go to 0 at this point. And so at the rising edge of the clock, input is 0, so that means Q3 is going to be 0. D2 is 0, so that means Q2 is going to be 0, and then since Q2 and Q1 were 0, D1 and D0, or the last two bit digits, are going to be 0 as well. And so long as the input remains 0, we're going to remain 0 for D2, and we're going to shift zeros into the most significant bit, so we will remain at all zeros on this clock edge. And the output, since it's the least significant bit of our shift register, it's going to remain 0 up through this point as well. Now, when in is going high again, we need to consider how this is going to affect D2. Initially, since the most significant bit, Q3, is 0, D2 is going to remain 0. But like before on the rising edge of the clock, we're going to shift in our new values. In is 1, so that means Q3 is going to be 1, and then we're going to get 0, 0, 0, just like we did before. And this means that D2 is going to take on the value of 1. And it's going to remain this way since both in and Q3 remain the same. And so on the next rising edge of the clock, Q3 is going to take on the value of in, which is 1. Q2, the second most significant bit, is going to take on the value of D2. D2 is 1 in this case, so it's going to get a value of 1. And then for bits 1 and 0, we're going to take on the values of Q2 and Q1, which were both 0, so we will have 0, 0 for these bits. And so up through this point, Q0 has still remained 0, so we will still be 0 for the outputs. Looking forward, the input remains 1, and the most significant bit Q3 remains 1, so that means D2 is going to remain 1. At the next rising edge of the clock, we see that in is still 1, so we would shift in a 1. D2 is still 1, so Q2 is going to get a 1. Now we have that Q2 is also 1, so that means our next bit is going to be get a 1, and then Q1 was a 0, so we'll have a 0 that shifts over here. And so at this point, our output is still 0 since the least significant bit is 0. For D2, up until this point, both in and Q3 are 1, so our value for D2 is going to remain 1. But now in goes to 0, so that means that D2 is going to 0. And then when we go to the rising edge of the clock, we see that for Q3 we're going to shift in a 0 since the input is 0. And since D2 is 0, that means the second most significant bit is going to be a 0. And then for the next two bits, we're taking on the value of Q2, which was 1, and also Q1, which was also 1. And so at this point, our output, which is the least significant bit, is going to become a 1. And then looking at D2, since the input is 0, it's definitely going to remain a 0 here. And while the input goes to 1, our most significant bit Q3 is still 0, so we would remain 0 at this point. Now at the rising edge of the clock, the input is 1, so Q3 is going to be 1, but Q3 at this point is 0, so the next bit is going to be 0. We're going to shift over the value of Q2 to Q1, and then for the least significant bit, we're going to shift over the 1 and have a 1 here. Now for the output, the least significant bit is still a 1, so it'll still be a 1 here. We now want to consider D2. The input is 1 and Q3 is 1, so that means we would go high at this point, and that's going to stay the same until something changes. The input changes to 0 here, and it remains 0, so that means for the rest of this it's going to be 0. And then looking at our shift register on the next clock edge, the input is 0, so we're going to shift in a 0. D2 is 0, so we're going to have a 0. We're going to continue to shift over our two previous values, so we're going to have all zeros, and that means our output is going to be 0. We can see that this somewhat behaves like a shift register, but it's a little bit different in how it deals with an input of 1. So instead of shifting out an input of 1 all of the time, it basically shifts out 1 fewer 1s than were in the input. So when input was high for only a single clock cycle, we didn't shift out a 1 for that. And when an input was high for 3 cycles, we only shifted out 2 of the 1s. So one way that this could be described would be to say that this shifts out 1 fewer consecutive 1s than are shifted in. If you shift in 1, you don't get any 1 shifted out for that. If you were to shift in 2, you get 1 out. If you shift in 3, like we saw, you get 2 1s out over 2 consecutive cycles, and this would continue from however many bits you fed in. And so that concludes our analysis of this specialized shift register.